So we've looked at our first reaction of the metals with oxygen, and from that we got a wee bit of information about the order of reactivity. We saw that they all kind of react with oxygen. I put copper in brackets there because it doesn't really react that well, it just turns black. But we've got them all reacting, and they all got different kind of scales of how vigorous they are. So potassium's very quick, copper's very slow. As you can maybe imagine though, it's not enough information for you to like really confidently give the order there, because it's kind of your opinion which one's more reactive than the other. So we need a bit more information. So the next reaction we look at, which might help us work out the order of reactivity, is reaction with cold water. And that is a reaction we've looked at last year. When we looked at the periodic table topic, when I say last year, I mean the topic we've just done, the year we've just done, we reacted the group 1 metals with water. So metal plus water went to metal hydroxide plus hydrogen. You hopefully remember that as the reactions in the big glass trough of the safety screen, and the fact that it all went on fire and lots of fizzing, etc. So that's still true. We looked at the group 1 metals reacting with water, and we had all these observations. This is taken straight out of your year 11 notes. We had it for lithium, sodium, potassium. We had all these observations. I'm not going to go through them because you've just kind of looked at them. And the equations are just as you had them at the time. So lithium reacted like this. So 2 lithiums reacts with 2 waters to make 2 lithium hydroxides plus a hydrogen. And that's going to be the same for all of them. Sodium and potassium. So just the same as last year. That's what I'm going through quite quickly for now. One wee point just to point out though, just on the back of this, I said I gave you all 3 of these just out of your notes from year 11 so you could see where they came from. Gonna put brackets around lithium though. As you might notice from our reactivity series, we've got sodium, we've got potassium. Lithium kind of would go here, but it's just not in the reactivity series we look at. They only picked 8 metals for it. So it's there, but strictly speaking, it probably won't come up in an exam this year, but there's no harm in knowing it because it's pretty much the same as the other 2. But the only 2, strictly speaking on the spec now, are the sodium reaction with cold water and the potassium reaction with cold water. Potassium is the most reactive, very vigorous. Sodium is still quite reactive, but not quite as vigorous as potassium. And in year 11, that's where we stopped. We just looked at those 3. But obviously now in this reactivity series topic, we've got to maybe look at maybe how some of the other ones react with cold water. If I come back to this wee summary table, what we'll actually find is that not many of them do. Cold water is not a very reactive substance, so only the very reactive metals will actually do anything with it. Aluminium down, we get nothing. You put those metals in water and nothing will take place. The only 2 we haven't looked at are these 2. Calcium reacts with cold water and magnesium kind of reacts with cold water. We'll look at that in a second. So we've got 2 more reactions to look at to finish off this cold water section. So the way we do this reaction is a wee bit different just because they're much less vigorous than the group 1 metals. We've got a slightly different kind of setup here. So to react calcium or magnesium with water, the metal is put in a beaker with water obviously, and an inverted filter funnel is placed on top with a boiling tube filled with water to collect hydrogen produced. So we're putting in a beaker rather than a glass trough. It's safe not to do so, but we might want to see what the gas is. So we said on the previous page that when you react metals with cold water, you make a metal hydroxide plus hydrogen. We might want to prove that though, so we need to trap the gas. To do that, we'd put a filter funnel on top, upside down. I'll kind of funnel all the gas towards the top. We put an upturned filter funnel on top, an upturned boiling tube on top filled with water. And as the bubbles are produced, they'll push out the water from the tube and you end up with a tube just full of gas, hopefully hydrogen. So that's the apparatus you would use in the exam if you're asked to draw the reaction of like calcium with cold water. So these reactions are a bit new to us. Obviously the equation is probably the first place to start. It's not actually that dissimilar. So remember, the key equation is still the same. A metal plus cold water goes to metal hydroxide plus hydrogen. So I'm just going to do that for these 2. You might want to pause the video, have a go yourself if you think you're up to it. But calcium reacts with water. This one's a bit more tricky. Going to do the working up here. So calcium's in group 2, so Ca2+. Remember, hydroxide's in the back of the periodic table, OH-. If I swap and drop that, I get calcium hydroxide as CaOH2, and I still get hydrogen. So to balance it out, all I actually need is a 2 in front of the H2O. Same with magnesium, is in group 2 as well, so it's going to have a very similar format. Magnesium plus 2H2O goes to MgOH2 plus H2. So equation first. Observations actually quite a bit of detail, specifically and particularly for calcium, they quite like asking about calcium's observations in the exam because there's quite a lot of key features to it. Also, it'd be nice if I could show you this in real life, but you have to cope with my description. If I put a piece of calcium into a boiling tube or into a beaker of water, quite a few things happen. The first thing is it sinks. So that's different to the group bond metals, which all float. So calcium sinks, but after a while, it will float again. Sounds a bit strange. It sinks then floats. The reason it sinks and floats is because it fizzes. At the start, it doesn't react that quickly and just kind of sits at the bottom. But as it gradually comes into contact with water, it fizzes, making hydrogen, and fizzes quicker and quicker and quicker. Eventually, it fizzes at such a rate, it's kind of like a wee jetpack, and forces the calcium up to the top of the beaker with all the bubbles being produced. So the fizzing causes it to float after it's initially sinking. It produces a lot of heat. It will disappear after a time. Sorry, make it a bit more specific. The solid disappears. And this is kind of sneaky one at the end. A metal hydroxide most of the time is just a colour solution. Calcium hydroxide is a wee bit different. This is only slightly soluble in water. It's not insoluble, but doesn't dissolve that well. So what we actually observe when we make calcium hydroxide in water, the term we use is it's a colourless solution with a white precipitate. So essentially it looks kind of like a cloudy white, but not like very a solid cloudy white. You see some colour solution, but we kind of pockets of white kind of powder within that. So that's just phrase you use, colour solution with a white precipitate. Magnesium is a little bit more easier to cope with. All you have for magnesium is that you get a few bubbles over a long time. So magnesium is kind of our limit of what will react with cold water from our set of 8 metals in this reactivity series. It does technically react, so if you put a piece of magnesium in cold water and stared at it for about a week, you would occasionally see a bubble of hydrogen being produced. It's not very vigorous though. We're not really going to get the magnesium eventually disappearing. You're not going to notice any heat really. So just a few bubbles over a long time is what you'll make there. Just going to write a wee note here just to make it completely clear. It looks like we're stopping halfway down our reactivity series. The reason is the rest of them just won't react at all. Magnesium barely reacts and it's quite reactive. Anything below that will do nothing. So the remaining metals don't react with cold water. Final thing on page 3, just a wee bit kind of revision. So we said we do this apparatus here for this reaction if we wanted to test the hydrogen produced to prove it is actually hydrogen. It's asking how would you do that? It should be drilled into your head by now. We use a lead splint and we will observe a squeaky pop if it is hydrogen. What type of reaction occurs when heat's given out, as a lot of these reactions do? We would call that an exothermic reaction is the term we would use there. So that's reaction 1, metals with oxygen, and now reaction 2 done, metals with cold water. We've got one more to look at.